All right, let's start off with this warm-up. So I would take a couple minutes, pause the video, try this out. Make sure you're super careful with your factoring and the subtraction once you get to that. Use your notes to try this one out. And when you're ready, unpause the video. Okay, so now that you guys tried it, let's factor the bottom of this first one. So if I am factoring it, I want to add to be 7, multiply to be, oh, let me get a pen that works. Add to be 7, multiply to be 12. So factoring that, it would be +3 and +4, which means that our first fraction does not have that x plus 4 in the bottom. So you needed to multiply the top and the bottom by x plus 4. So remember, when you're doing this, we're going to keep the bottoms exactly the same. We're not changing them. And on that first one, we are going to multiply out the top of the fraction. And that second fraction stays the same. It's just a 1. So if I multiply out the top of the first fraction, x times 2 is a 2x, and 4 times 2 is a +8. So now that I have my bottom of my fractions exactly the same, and I multiplied out my top, I'm going to do my subtraction part. So 2x plus 8 minus the 1. My bottom is going to stay exactly the same. And 2 actually doesn't change, but 8 minus 1 is going to leave me with 7. Now, if I check the top of that, 2x plus 7, there's no way to really factor that any further. So we are done with this problem. We've simplified it as much as we possibly can. We do need to state our domain. So what can the bottom not be equal to? So if I set x plus 4 equal to 0, it would tell me that x cannot equal -4. And if I set x plus 3 equal to 0, it would tell me that x cannot equal -3. All right, let's try some of the notes now. Let's take a look at it. Okay, so we've done a lot of adding. We've done a lot of subtracting. Now we are going to solve. So now we're adding in some equals to our equations. So now that we have this equals, I am going to do 2 different methods in this section of notes. Now you can choose, but this first method only works with this type of problem, and I'll explain that. And I'll show you after this a different way to go about solving these that works no matter what kind of problem you have. So with this problem that we're looking at right now, we have a fraction equals something. There's only one thing on each side of the equals. So when you have that, we can do cross multiplication. Now with cross multiplication, you do need a fraction equals a fraction. So since it equals to 2, we know that a whole number is divided by 1. So we're going to do that on this first one. Let's zoom in, let's look at it. So I'm going to do cross multiplication since I have a fraction equals a fraction. I'm going to do the 1 times the 1, which is just 1, equals, and I'm going to multiply 2 times the x plus 4. Now that I've done that, I can just solve the way I normally would solve. So I'm going to distribute, multiply this all out. 2 times x is 2x. 2 times 4 is 8. And then I'm going to start to solve for that x. I'm going to subtract 8 on both sides, giving me -7, and I'm going to divide by 2, giving me x is equal to an ugly fraction. I'm going to just leave it as that. I'm not going to put it as a decimal. You could really put it as a decimal if you really wanted to. And with these, we got to always double check when we're doing something with an equals that we don't have our solution as part of the domain. So if we look at the bottom of each fraction, if I set x plus 4 equal to 0, that meant that x could not equal -4. And if I set 1 equal to 0, it doesn't tell me anything about x, so I don't really care about that. But we made sure that our answer did not include -4. So we are okay with the answer of -7/2. All right, let's try that again on the next problem. Okay, let's slide over. We have, again, a fraction equals, and it's a number, but we know a whole number is divided by 1. So we have a fraction equals a fraction. When you have that, again, you can do that cross multiplication. So let's do that. 1 times 1 gives us 1 equals the 5 times the x minus 3. So let's just solve the normal way, starting by distributing that 5, giving us 5 times x is 5x, and 5 times -3 is a -15. All right, I'm going to start to solve for that x, so I'm going to add 15 on both sides of my equals, giving me 16 equals a 5x. And I'm going to divide by 5 on both sides. Again, ugly fraction. If you want to put a decimal, you can. I personally just like to keep it as a fraction so I don't have to do any rounding. So I got 16 over, that's a 5. So let's double check our bottoms of our fractions. X minus 3 would tell me x cannot equal +3. And the bottom of this 1 equals 0 really doesn't tell me anything about x again. So we made sure that our answer did not include the answer of +3, so we are good with the answer of 16 over 5. And here's both of those problems if you need to look at them one more time. All right, let's try another problem. Now this one looks a little different than the last ones we just did because on one side of the equals we have 2 fractions and they're being added together. So if you don't like the cross multiplication, this is the method that you can use no matter what. So, but you have to do this method if you do have 2 fractions on both sides. So the first thing with this, when you have 2 fractions on both sides, or a fraction on each side of your equals, the first thing you're going to do is you are going to find common denominators. So I need to figure that out. So looking at the bottoms of each of my fractions, the first fraction and that fraction on the other side of my equals both have x's, but this middle one has a 4. So I need to add those things that are missing to each of the fractions. So the first one has an x, but it doesn't have a 4. So I'm going to multiply top and bottom of that one by 4, giving me 4x on the bottom. Now the middle one has the 4, it doesn't have the x. So I'm going to multiply both of those by x, again, to make my denominator 4x. So I'm making them all the same. And then my last fraction has a x, but it doesn't have a 4, so I'm going to multiply top and bottom by 4. So let's do that. Let's multiply it all out, see what we get. So on the first fraction, 4 times 5 is going to give me 20. And my denominator, 4 times x, is 4x. My second fraction, 7 times x, is going to give me 7x over 4 times x, which is 4x, equals, I'm going to put that negative with the top number. So -9 times 4, is going to give me a -36. And on the bottom of that, we have 4 times x again, 4x. So now that I have all of my denominators the same, I have a trick. The bottoms really don't matter anymore. Now that the whole thing is the same on the bottom, I want to just focus on the top. So what I would do is get rid of the bottom. I know that sounds weird. And I want to figure out what's going to happen with the equation on the top. So 20 plus that 7x is equal to -36. So now I can just solve the way I would normally solve. So get rid of the bottoms, and then you're going to solve for x. So this process works every single time. If we could go back to those problems we just did, and we could do them the same 3 steps, and it would give us the exact same answers. So let's do that. We're going to solve on this one. I'm going to start off by subtracting 20. And it's going to leave me with 7x equals a negative 56. And then finish that off by dividing by 7. So x is equal to a negative 8. Now, as always, if you want to add this step to the end, we want to check our domain. Make sure whatever x cannot equal was not part of our answer. So if we look at the bottom of all those fractions, we had a 4x on all the bottoms of our fractions. So if I take 4x and set it equal to 0, I would divide by 4 on both sides, telling me that x cannot equal 0, which is perfectly fine because our answer was negative 8. All right, I'm going to go to the next slide. If you need to pause to write anything down, go ahead and do so. All right, let's look at this next example. We're going to follow those same steps we did in the last problem. So first of all, I don't have a fraction on this first number. So it's a 1, which we know a whole number is divided by 1. So now that we have a fraction, I'm going to start off by finding common denominators. So my middle fraction has an x minus 5, and my last fraction has an x on the bottom. So I need to make all my bottoms be exactly the same. So this middle one needs that x that the last one has. So I'm going to multiply that one by x. The last fraction doesn't have an x minus 5. So I'm going to multiply by x minus 5 on top and bottom. Now the first number doesn't have an x or an x minus 5. So I'm going to multiply by both of those things. Make sure all of my denominators match, because once they match, I can get rid of them. All right, so let's multiply this out. My top of my first one is going to be x times an x minus 5. Actually, we want to multiply the tops out, so let's do that. X times x would be x squared, and x times a negative 5 would be a negative 5x. And then I don't really care about the bottoms multiplying them out because I'm going to get rid of them in a second. Minus 8 times x is an 8x. Again, my bottom of my fraction is now the same, which is what we were shooting for. And then I'm going to multiply that top out of that very last fraction. 3 times x is a 3x. 3 times negative 5 is a negative 15. And I'm going to keep the bottom the same. So now that I've done that, I can get rid of the bottom of the fractions. So I have x squared minus 5x minus an 8x equals a 3x minus 15. So I'm going to start to solve this. I have x squareds in this. So this has been a while since we've solved with some x squareds. It was last semester. Let's do a little refresh in our brains. So what I'm going to do is I'm going to try to get everything to the same side, set it equal to 0, and see what I can do. So I'm going to move that 3x over. I'm going to subtract it. And all those x's are going to be able to go together, which is awesome. And I'm going to also add that 15 over. So we have 0 on that side of the equals. So let's put everything together, make this look way nicer. X squared is just x squared. And then we have all these x's that can go together. So negative 5 minus 8 is negative 13. Minus a 3 is a negative 16x. So I just put all those x's together. And then plus 15 doesn't go with anything else, so I'm just going to put it on the end. So now that I have this, I have it set equal to 0, I can solve by factoring. Let's see if we can factor this. So to factor, we're looking for two numbers that multiply to be 15, add to be negative 16. So, I'm thinking an x minus 15 and an x minus 1. That would give us a positive 15 when we multiply, and it would add to be negative 16. Awesome, there we go. So to solve, just like we would do kind of with our domain, we're going to take both of these and set them equal to 0. So x minus 15 would give me an answer of x equals positive 15. And x equals positive 1 if I set x minus 1 equal to 0. So here's my two solutions. Now let's check our domain. So looking back at the bottom of my fractions, we had an x on all the bottoms, and we had an x minus 5 on all the bottoms of the fractions. So if I do x equals 0, so x cannot equal 0. And if I do x minus 5 equal to 0, it would tell me x cannot equal a positive 5, which we did not have the answer of 0 or 5. So both of these answers are okay. So that last problem after this one, I want you to take a second, pause the video, and try it out on your own. And once you're done or need some help, head on back to the video and see how you're doing. All right, now that you have tried this out, let's try it together. So depending on the method that you used, you could have picked either, because we have a fraction equals a fraction. So with that, we could cross multiply. Now, just to be fun, I'm going to show you how to do it with the other method in case you like that one better, because you could use common denominators no matter what you have when you have an equals. So if I am using common denominators, let's do it. We need, on the first one, we have an x plus 2. On the other one, we have an x minus 2. So we need to make them exactly the same. So I'm going to multiply this one by the minus 2 on top and bottom. And I'm going to multiply this one by the positive 2 on top and bottom. All right, now as always, we are going to multiply the tops. Don't care about multiplying the bottoms out because it should end up exactly the same on both, so we can get rid of them. So on the top of this first one, 3 times x is 3x. 3 times a negative 2 is negative 6. All right, the bottom of our second one, again, should end up exactly the same as the other one. That is the point of common denominators. But we are going to multiply out the tops. 5 times x is 5x. 5 times 2 is 10. So now that we have denominators exactly the same, we don't care about them anymore. Let's just focus on the top. So we are just going to solve. Oh, this is nice to solve. I'm going to subtract the 5x on both sides. Get those x's together to give us negative 2x minus 6 equals a 10. Then I'm going to add 6 to both sides. Start to get that x alone, giving us negative 2x equals 16. Oh, this is looking great. And I'm going to divide by that negative 2 on both sides to give me an answer of negative 8. Now let's double check our domain as always. We had an x minus 2 on the bottom of our fractions, telling us that x could not equal positive 2. And we had an x plus 2 on the bottom, so x could not equal negative 2, which, no matter what, our answer was negative 8, so we were good. All right, everybody go try that 4.5 worksheet number 1. And if you have any questions, as always, ask.